This talk, as you can see here, is going to be a talk about a tool called Flyway. I'll briefly introduce myself first. My name is Joris Kuipers. I work for Trifork for almost 6 years now, mostly as a hands-on architect, as I like to call it, which means I do coding and not just drawing pictures. Also fulfilling a CTO role nowadays, and on occasion I still teach the occasional Spring training. I have a background in Spring because I used to work for SpringSource. For this presentation, the tool I'm going to be talking about is Flyway. I've been working with that for about 4 years now on a number of different projects. And over those years, I've developed some patterns for using it, which led to the inspiration for this particular talk. So what I'm going to do is I'm going to do a brief introduction of the tool itself, for those of you not familiar yet with what Flyway is and how it runs. And after that, I'm going to cover a number of patterns, of ways of using Flyway that I came up with in certain situations for different types of projects. So that's basically going to be the talk. So what problem is Flyway trying to solve? Well, the thing is, if your application is using a relational database in its day-to-day operations, you're going to have a database schema. And that schema will typically evolve as you are growing the functionality of your application. So first of all, how do you actually track the changes that you want to make to that schema? You may add new, let's say, JPA entities, for example, that require new database tables to be created. How do you make sure that those create statements will actually be executed before your application is running and expecting those tables to be there? How do you deal with changes like additions of columns, renames that need to happen? Maybe also certain operations that actually require changing data rather than your database schema, like reference data. And for example, I used to work on a project where this was basically tracked in a file per release. So we would have a file containing SQL statements and saying, oh, well, if we're going to go from release major version 8 to major version 9, we're going to have a migration file called 829 migration.sql or something like that. And whenever we need a new table and we know it will be part of the next upcoming release, we'll just put a create table statement in there. So then at least you have it version controlled, so that helps. But then the other problem becomes, okay, when we're actually going to deploy, how do we ensure that these changes will actually happen against the production database? And I still see a lot of teams, and I used to be guilty of this same thing myself, where we say, well, that's just a manual step. Right, before we're actually going to go in production, we're going to check that file and we're going to run those SQL statements, going to verify manually if they actually worked or if there was some unexpected error and some constraint violation or whatever. And then we'll take it from there. Obviously, that's less than ideal. You typically want to be able to automate these sort of things. And when you start to automate, it also becomes important to think about, okay, but what changes have been applied already? So in the example I mentioned, let's say we're having a project that is doing a major release every month or so. We have this file where we build up all of the changes that we need to make. That will work on production if you say, yeah, production is always on a major version, so it's currently on version 8, then we're going to deploy version 9, we're going to run everything in that 829 migration file. But in the meantime, you might have a test environment where you want to be able to deploy every day maybe to test functionality that's under development. And that means that part of what you already had in that file will have been applied already on that test environment. So you cannot just run the full file with every statement, right? You need to be able to somehow figure out which parts have been applied already. Hopefully, people will only append to that file, but if they don't, you also need to make sure that changes that were applied already haven't been changed after the fact because someone found out that they made a mistake, so well, we'll just fix it and pretend it never happened. You cannot do that with a database, right? So that's the sort of thing that Flyway aims to help out with. It's a tool. It's written in Java. You can integrate it in your application, or if you prefer that, you can run it as a separate standalone tool. And basically what it does is it tracks and applies things that it calls migrations, which are typically just files containing SQL statements. That's it. So what it will do is when you start up this tool, it will first check in your database, because it keeps track of that, what changes have been applied already, what's basically the current version of your schema, what migrations exist in your application, in your Flyway configuration that have not yet been applied, and it will then apply the new migrations. While doing that, it will also perform some validation, so it can check if your database is actually in a consistent state, so that it can safely perform those migrations and not do something that would actually be harmful to your data. So if you only remember one thing from this presentation, it's that Flyway is basically version control for your database. Right? That's what it aims to be. So I'm going to talk a little bit first about what it means to apply these migrations with Flyway, what steps are being taken by the tool. And after that, I'll proceed to some more advanced scenarios. So applying migrations basically means that Flyway will first need to find what migrations you have at startup. So as I said, a migration is typically just a SQL file containing some DDL statements, data definition language statements, like create tables, alter tables, those sort of things. That's not the only thing that's supported. You can have Java code that runs as a migration if you need to perform some application logic as part of your migration. Maybe you need to encrypt some data, for example. And it will search for those files, SQL files and or Java migration classes, in a number of specified locations. There is a default, I'll talk about that later on. Basically, it's just a package in your class path. In that directory, it will search for files that are conforming to a certain naming conventions. So by default, you need to start with the prefix v to say this is a version migration. You have a version number, and then after that you can have some description. So what you see here is an example of an actual project that I'm working on where we say we have a migration that is versioned with 9, but because we like our numeric ordering to be the same as our alphabetic ordering, we prefix that with some zeros. Then we have a double underscore, which means the version is done, and everything after that is just a description of what that file contains. So that's your migrations. Once Flyway knows what migrations exist in your code, it will also check what migrations have been applied already to your database. Because in the typical case, there will be some migrations that have been applied already. And it keeps track of all of these things in a custom database table that's just for Flyway. That table is called Schema version by default, and there are a number of columns in there that you can see here. It will remember, okay, what file did I already apply, in what order compared to other files did I do that, when did I do it, what database user did I use. You can see all of that information here. One thing that's particularly interesting is this checksum that you see there. What Flyway will do is it will calculate a checksum hash of every file that it successfully applies, and it stores that in a database. So next time that it runs, it can actually see if that file was untouched. Because if someone changes a migration after the fact, well, there's no way for the tool to know what should happen, because the contents of that file might have changed, and there is no way of comparing that against the actual database state. So that's why there is a checksum there as well. Now, typically, and by default this is enabled, before applying any new migrations, Flyway will perform some checks against your database to make sure that it's in a known state and that it's safe to start migrating. First of all, we'll check, do I have my own schema version table already there? And if you have a completely empty database schema, no tables whatsoever, it will just create that database table for you automatically, assuming that you have sufficient right for that. If it does find existing tables, but it doesn't have its own schema version table, by default it will fail. It says this is another database, I'm not sure what to do, but I'll talk about how to deal with that situation later on. Also, it's going to check those checksums, right? So for every migration that you have, it's going to calculate a hash, it's going to compare that to the applied migrations, and if there are any mismatches, it will fail. Because there is, all bets are off basically if someone starts changing already applied migrations after the fact. Flyway doesn't know what that means, so you have to fix that yourself. Then it's going to see, are there any migrations in that database table where we have recorded that they have been applied already, but those migrations somehow no longer exist in the available migrations that you want to apply. By default, Flyway will consider that to be an error if those applied migrations have an older version number. So that would basically mean if you have removed things after the fact. It could be that your database has some applied migrations that have a higher version number than any of the available ones. And that is a situation where you're basically rolling back to an older version of your application. And by default, that's considered to be okay. Flyway says, well, okay, I can see that all of the migrations I have are applied, but apparently some newer ones have been applied that I don't know about. That simply means that that must have been a newer version of your application. You can always roll back, assuming that your application is still compatible with the database schema. All of these things can be tuned, by the way. You can enable or disable all of these features as you see fit. But the defaults are pretty okay. So then, if validation succeeds, it will actually start to apply all of the newer migrations that were not applied yet. And it will do that in order, simply orders them by version number. And then for every migration, so for every SQL file, is that what that typically means? It will use a database transaction. Now, if that helps or not completely depends on your database, right? If you're using MySQL, there are no transactional DDL statements. A create table statement in MySQL is inherently non-transactional. You cannot do a rollback and pretend it never happened. On the other hand, other databases like Postgres, for example, do support this. So there you actually get an atomic application of a single migration file. Recent versions of Flyway have actually added a feature where you can say, well, if my whole migration is going to consist of, let's say, 5 different SQL files, I'm going to have a single transaction spanning the whole thing. Nice thing about that is that if anything goes wrong during the migration, you can just do a complete rollback to the original state of your database, right? You won't have something hanging in the middle where you need to figure out what went wrong and then fix it. For all applied migrations, it's going to create entries in that schema version database table. And if anything goes wrong in this whole process, it will just throw an exception that would typically mean that your application fails to start up, assuming that you're running this during startup. Or if you're doing this as a separate tool, it will just fail to do that. You will need to figure out then what happened. And there is no automatic way to fix that, so you will need to do that. What you need to do there exactly depends a little bit on if your database supports transactional DDL statements. If you have something like MySQL, what will happen is there will be an entry in the schema version table where Flyway says, this has been applied, but it failed. So you need to fix it and then mark it as successful. On the other hand, if you do have transactional DDL support, like in Postgres, it will just roll back the whole transaction. You will not have any line in your schema version table for things that weren't successful, right? So every migration is by definition then either successful or not applied. So typically, like I said, the migration contains DDL statements. You want to add tables, you want to add columns, you want to maybe do renames or delete stuff, right? That sort of thing. On the other hand, it's just SQL, so you can do anything you like in those migrations. So a typical other use case for Flyway is to insert things like reference data, where you don't need a, let's say, a UI or a front end for people to do administration of this, because you just want to add maybe a currency or a country to a country table or something like that. But you do want to make sure that that is applied to all databases in all environments that your application is running in. So that's also a really nice application for a tool like Flyway. If you need logic, complex logic, as part of your migration, as I said, you can actually implement a migration by implementing an interface in a Java class. And then you will just be able to use JDBC code to directly interact with your database. And the result of that will be considered to be an applied migration. So that's basically how it works to typically apply Flyway in a project. So some things to consider when you want to do this is, first of all, do I want to run this at startup with the rest of my application code, or do I want to run this as a separate tool? I typically prefer to do this in my application, because it makes sense that if your application starts up, it will just make sure that the database is in a expected state, basically, and then do the rest. However, that does imply that the database user that you use to connect to your database has sufficient rights to actually change the schema, for example. There may be environments where this is not allowed, and in that case, well, you're probably going to end up using something like a continuous deployment pipeline, where applying Flyway will be part of your deployment pipeline using a different database user. So you can do that. Also, if you do it in your application, make sure it happens as the very first thing that talks to your database, right? You don't want something like JPA, let's say Hibernate, to start up, seeing your old database schema while you are still busy applying all of those changes. So in a Spring app, for example, you typically do this simply by making things dependent on a Flyway bean. If you have some other mechanism of bootstrapping your app, well, you can just figure that out yourself. So that's some things to consider. Also, this is by design. This is not a missing feature. Flyway has no support for automatically applying some sort of undo to roll back to a previous version of your database schema, because there is no generic mechanism for that. If you're going to do destructive operations, like deleting a table, dropping one, or dropping a column, or other types of things, there is no generic way for Flyway to say, yeah, I have a good way of just undoing that. So instead of trying and then working a little bit, it just doesn't support it. So make sure that you have backups in case you do need to restore to a previous version of your database in case something goes wrong. If you do have a database that supports transactional DDL statements, that helps, of course, because then at least your migrations can be atomic. They can be all or nothing. You won't leave your database hanging in some in-between state there. Also, make sure that when you start using this tool, that you use it for all of your database changes. Don't fall into the trap of saying, yeah, but you know, for this environment, we need this right now. I'm just going to manually change the schema for now. Because then that change is not recorded anywhere. If you do make that same change later in Flyway and you try to apply that migration, it will probably fail because it says, well, I already have, let's say, a new column with this name, that sort of thing. So basically, changing your database schema by hand would be considered the same as hot patching your code in production. And you should never do that, right? Because people that know me know that I would never hot patch code in production. So that's Flyway in a nutshell. Now, with this knowledge, you can go back to your projects, and especially on new project, you can start using this. And what I suspect is that quite quickly you will find that you run into some issues with Flyway. And I'm going to present you with some solutions to those issues. And the first one is, what happens when you start working with a project that has maintenance branches for a production version that you may need to patch, and on the other hand has a master branch or trunk-based development for people who still know what trunk is, where you're going to do your upcoming release. What's the problem with this? Well, I'm going to show you a picture of what will happen when you start to apply Flyway with this common pattern. Basically, let's imagine that our database schema is currently on version 0 of some migration. And then we apply some other migration, so now we are at version 1. And at this point in time, we say, yeah, this looks good. We're going to bring this out into production. So right now, version 1 is your production version, and we're going to create a maintenance branch for any future maintenance work that we quickly want to bring into production for patching. And in the meantime, we're going to continue working on master or trunk or whatever for the upcoming next major release of our version products. So ongoing development for the new release is happening. So we are developing a migration version 2. We are developing a migration version 3. But these things have not yet been applied to the production database, mind you. This is just in source control. And now we find that we have some issue in production, and someone is going to create a fix. And as part of that, we need to change the database. So probably you had a default varchar 255, and it turns out to be too small to hold all of the data that your user is entering in some common form, for example. So we're going to add a migration then on the maintenance branch. But what version will we give this? You could say it's going to be 4. Because every change that you make on the maintenance branch will be merged back into master, and then things will still work out. However, if you do that and you would deploy that, then you're going to jump in production from version 1 to version 4, which is actually okay as far as Flyway is concerned. But then later on, when you're going to deploy your master branch, all of a sudden you have version 2 and 3. But you're already on version 4, and by default, Flyway says, that's not going to happen because these things need to happen in order. So basically, you need a version number that sits after 1, because we want to apply it after the current production version. But it needs to come before version 2, because version 2 is the thing that we're actually going to deploy with the next major release. So the solution for this is actually quite simple, because Flyway supports things like major, minor version numbers, where you can have actually as many parts of a version number as you like. So in this particular scenario, what we can do is we can say, well, if the database schema needs to evolve in a linear fashion, right, you cannot branch your database schema itself. We're just going to use a version number like 1.1. And if we're going to deploy a patch to production with version 1.1, it will be recorded as being newer than version 1, obviously. But if we merge that back into the master, and then we deploy that master later on, also containing newer migrations like version 2 and version 3, those will still be logically after version 1.1, even though in time we actually created this one after we created the migration version 2 and 3, and everything works fine. So on production, what that means is that we go from 0 to 1, then we do a hot patch, so now we are on 1.1, and now we're going to apply the next major release, so that will bring us to 2 and 3, and everyone's happy. However, you may have a test environment where you are continuously deploying the things that you are doing on master. So in that case, what will happen on the test environment is we are in version 1, and now we are developing new migration version 2, and we're rolling that out immediately as soon as it's available, and we're doing 3. And now we merge back this maintenance branch, and we try to deploy that, and now we want to apply 1.1. So can we do this? The answer is, well, not by default, because by default, Flyway is going to tell you this version 1.1 is lower than the current version 3. That's not going to happen. You must have made a mistake. You must have accidentally merged something in that wasn't there before. But in this case, we know what we're doing, and we actually want this behavior. So you can tell Flyway, I don't want this check to be applied. And you can do that by changing this out of order property on Flyway itself. You can, by default, it's enabled, but you can say disabled, but you can say I want to enable the out of order. And in that case, it simply won't check the order. Now, by doing that, you lose some safety, obviously. So in this case, you only need to do this on non-production environments where you're going to be deploying your trunk or master before it's actually a proper release. So what I like about this pattern is that if you use this version schema, then on acceptance and production, you can leave the out of order disabled. And Flyway will provide you with the safety that you will always apply only newer ones. Whereas on other environments where you do continuously deploy, basically, you can just enable this feature and everything will still work out. Now, this will start to break down when you start to develop in a slightly different fashion, namely when you start to do a lot of work on feature branches. So feature branches is another popular approach to do version control or software configuration management, where instead of just developing on master or trunk with everyone, you're going to have separate branches for new features, and then when they're done according to some definition of done, you're going to merge them back into the master. And this is an orthogonal concern, basically, to if you do maintenance branches or not, right? You can mix and match these models. So what are the problems with applying feature branches? Well, actually, that's a talk. It's not even a talk that I have to do. There are people who have entire talks on this. So if you're interested in this, make sure to check out a talk from Sam Newman. He's mostly known for being the microservices guy. He wrote the book from O'Reilly. But nowadays, he's actually doing a talk with the fashionable title, Feature Branches and Toggles in a Post-GitHub World. But it's on YouTube. You can find it there. And I do recommend looking at this because I think it's interesting food for thought. I don't necessarily agree with everything he says there, but it's definitely something to think about. In the context of Flyway, however, what are the problems with feature branches? Well, let's say we are again on version 1. And now we're going to spin off some new feature branches. So we have 2 branches in this case. First team in feature A branch says, oh, we need to have some new change to the database schema, so they're going to add a version 2 that will be merged back into the master when it's done. And now feature team B also says, oh, we need a new version, and we're currently at version 1, so we're going to create a version 2. One of these teams will be done first, and they will merge back into master, and that will just work. So now we have 0, 1, 2. That looks good. Now feature team B is done, and they're going to merge back into master. And now we have another version 2 migration. And this is not good. Flyway will not allow you to have 2 migrations with the same version number because, well, we don't know in what order they need to be applied. I have seen teams fixing this by using things like placeholders for version number, and then after merging, you have to manually fix that placeholder number. Or it's just a procedural thing where we say we do actually merge it like this, but then directly after the merge, we're going to change that letter version 2 to version 3. If you're only going to do a small number of feature branches and features at the same time, that might actually work out for you. However, on a bigger scale, this is going to be a complete mess because people will forget about this process. They will include double versions, and you will see failures then after that.
Do versions have to be numeric?
Yes, versions do have to be numeric, but they can have multiple parts. But it is definitely numeric, yes. So a nice solution that I've used for this a lot is to say, well, if we're going to have feature branches anyways, and things will be merged back in when they're done, order of those migrations probably isn't really that important anyways, because this is going to be, the whole thing about feature branches is they're going to work on different features. So they're going to change different things to your database schema. So you can assume, and this assumption holds very true, is my experience for most projects, that migrations, Flyway migrations that you create on feature branches can be run in any order. Now, when that assumption is true, you don't need strictly increasing version numbers anymore. So what you could do is you could just use timestamps. For example, here we have a migration called 2017-925, so that's a date, and then followed by an hour and a minute as well. I'm assuming that minutes will be granular enough for your typical feature branches. You don't need to go down to the actual second. And then we have our description. For this, you do need to enable out-of-order migrations in production. And what will happen then is that you're going to have a master which develops with version numbers that look like this. Then we're going to have feature branches. Feature A team says, oh, we need to apply a new migration, so they're going to come up with a version number. In this case, it's 11 in the morning on the 28th. Feature team B also creates one, which is actually a more recent version number, but they merge first. So they end up here on the master branch with their migration. And then later, feature team A is done, and they merge, and they get their migration in. So you can see that the ordering here is no longer a version in order. If you are going to immediately deploy features after they have been merged to master, so you're doing continuous delivery-like development, then this will only work if you enable out-of-order migrations, because otherwise Flyway will not be able to first apply that version that ends with 1230, and then in a later run apply the other one. Right? But that's, in this case, like I said, if you're doing feature branching anyways, you probably don't really care about those orders, so it's a good thing to forgo. Another thing is, by default, Flyway will look in a single folder to find all of your available migrations. And it will simply apply those. And that works for many people, just sticking to that default. But you can do some stuff with this. So one problem, if you're going to write DDL migrations, is that you're going to write them in a SQL dialect, which is typically specific to your database management system. So what if you need to support multiple DBMSs? And Flyway itself does not try to support this by itself. There are other tools like Liquibase that actually do this, where you're going to write migrations on a higher level, but I actually like being able to control the SQL that's being executed. But it's a thing, and a special version of this is, I see a lot of teams doing this, where they're saying, I want to run my integration test on an in-memory H2 database, and that's never going to be the same thing as you're running in production, obviously. And also, if I'm going to use something like JPA, and I'm a lazy developer, and who isn't, I'm just going to ask Hibernate to create most of the database schema for me when I'm creating new JPA entities, and only maybe a handful of tables that is not covered by JPA, because you're just going to use plain JDBC for that. I just need some create table statements for that for my integration tests. So again, you have a complete mismatch between the migrations that you want to apply to a production-like environment versus what you want to do using an integration test. Other things that can come up here that I've seen is when you say, I'm going to use Flyway to not just do my schema migrations, but also to do things like data fixes. I've worked on a project where they had a lot of contracts from people that would sometimes need fixing because of wrong data got in from third-party systems or data was missing, and they were releasing very often. So it actually made sense to say, well, if we need to do a controlled way of changing that data in the database, we're just going to use Flyway for that as well. But that data is only going to exist on production, maybe on acceptance if you copy over data from production to acceptance on a regular basis, but it's not going to exist anywhere else. So again, you have this problem where you have some migrations that should be applied some of the time, but not all of the time. So how do you do that? And how do you still make sure that your regular migrations are always applied? And solution is you can use different migration locations. A location is basically just a folder, the place where Flyway searches for migration files. And by default, that will be a package DB migration in your class path. But you can change that, and it can be more than one location. It can be a whole list of locations. And you can do this at startup, especially if you programmatically control Flyway. That's really easy. So if you want to support multiple databases, a very easy thing to do is simply have a migration folder per DBMS. And then at startup, you're going to find out, am I talking to H2 or to Postgres or to MySQL or whatever you need to support. You're just going to use the right folder for that. This is what that would look like in code. Here we have some code that starts up Flyway, in this case using a Spring Bean. But the important thing here is that we're calling a helper method here called getLocation. as you can see. And that returns a string array with locations, because Flyway expects a string array there. We pass in the data source there. So what could you do in a method like this, get locations? Well, you could basically find out what database am I talking to. So this is an easy way to do that. If you look at this piece of code, it says, well, if the JDBC URL, just using some metadata here, starts with H2, must be H2, and we're going to use a migration folder called DB migration H2. If it's not that, if it's Postgres, we're going to use DB migration Postgres. If it's something else, that's actually completely unexpected, because this application only supports those two databases. So we're just going to log a warning or an error, and we're not actually going to do any migrations, because we have no idea what database we're talking to. I actually used this and developed this very code that you saw on some projects, and then later on it turned out that other people had exactly the same idea. So this feature is now actually built in if you're using Spring Boot, because when you're using Spring Boot you can configure the Flyway locations, and you can use a vendor placeholder there that will automatically be replaced with MySQL or Postgres, one of those things. And it's exactly this very pattern. You can also use this for saying only when I'm running on something like acceptance or production do I want to apply some additional migrations that do data fixes. So you see an example of that here, where we're saying, well, if I'm running against Postgres, because that would be our production database, and if I have not disabled this additional folder, then I'm just going to return these two strings. I'm going to say we have a Postgres folder with regular schema migrations, but in addition to that, I'm going to have a folder, which I've called PostgreSQL data here, that's going to do data migration. So it's going to do fixes on the actual contents of your data rather than on the corresponding schema. But you can disable this with this feature flag that I've called skip data migrations. And if you do that on your development, your test environments, it will simply not run those migrations, right? So that's another pattern you can apply there for locations. Now, assuming that you've become enthusiastic about this whole idea of using Flyway, and you start to apply this to an active project, what you will quickly find is that you're going to create a lot of migrations. And with a big team on a big application, this can easily run into the hundreds in just a matter of months. So that can get in the way. It's not very nice if you have your IDE open and you open up this DB migration folder, and then the only thing that's left in your project explorer is SQL files, right? And you need to scroll down to the end to see, oh, what is it that we're actually working on at the moment, because the rest is just old history. The problem is you cannot simply delete those migration files. First of all, you always need a way, when you run against an empty database, to have Flyway create the entire schema. So just deleting stuff is not an option. Also, Flyway won't actually like it if you simply start to delete migrations that have already been applied. By default, it will fail during the validation for that. So the obvious solution is to say, well, I'm just going to take basically what is the net result of applying all of these hundreds of migrations. I'm going to put them in a single file. So I'm just going to squash them down. So that's what you have to do actually in this case. What I typically prefer is to have one file that just contains the DDL statements. You can create that, right? Just go use MySQL dump or PG dump if you're using Postgres or whatever. Run it against your production schema, and you will have exactly the schema that you are running on production. And then in addition to that, you can have a file that contains all of the insert statements for your reference data. So that's obvious. The problem is, if you're only going to do this, well, you're going to delete all of your old migrations in source control. You're going to add 2 new ones. But those 2 new ones that you're going to add shouldn't be ignored, right? Flyway should not be try to actually create a whole schema again when you run it. There is already a database schema in this situation. So how do you do that? And also, how do I enable this to simply not complain about all of the old migrations that I'm going to be deleting from source control? Because I don't want to leave those hanging around. So there's a pattern for this. And this pattern that I came up with also ensures that you can actually start to create these squashed migration files without having to tell your entire team, you have to now stop adding new SQL migrations in Flyway until we have actually rolled this out into production, because that's the sort of thing that I really dislike, especially since I'm usually not full-time on a single project, right? So if I develop something like this, I say, I'll be back next week, you cannot tell the team, and in the meantime, don't do anything. So what's the pattern for this? Well, I'm going to use a feature that I haven't talked about yet for this in Flyway called rebasing. So what's a rebase? A rebase is a way to apply Flyway to an existing database schema. So basically, when Flyway starts up and it discovers that there are already some tables in your database schema, but it's not having its own Flyway schema version table, you can tell it, that's okay, just assume that this database is already on a given version, that's called your baseline version, and just take it from there. So this is a very easy way to start applying Flyway to an existing project, right? That in itself is a really cool feature. A lot of people that I talk about Flyway are scared that they won't be able to introduce this to an existing project. So they're gonna hold off until they start a greenfield. There is absolutely no reason to do this. You can easily start this on an existing project. However, you can use this rebasing feature for other purposes. So for the purpose of squashing, what you can do is you can first define the current database schema in 1 or 2 files on a given date. And you do this on a feature branch, because you may not be able to apply this directly. Then, when you're done, you're gonna merge those things into the branch that you want to deploy. You're gonna delete all of your old migrations, and you're gonna use a trick here. You're going to tell Flyway, oh, by the way, the table name that you use to store your schema version, that's going to be a new name. So I'll try to show you what will happen in this case. First of all, we have an existing schema. So you start to develop, you start adding more migrations, and this thing becomes unmanageable, so you say, I need to squash this down. First thing you'll do is you're going to create 1 or 2 files that contain your entire database schema as it is at that particular point in time, right? So that could be a file like we see over here, where we have an initial schema and a reference data. You're going to do that on a feature branch. In the meantime, the rest of your team will just keep on adding new migrations, because that's part of developing the application. That's okay in this case. So you will see other migrations happening on the master as well. Then, when it's time to start deploying this, you're going to have a look, and you're going to say, what is the current version of the database schema in production, or in the environment that you're applying this to, rather. That may not actually be the version that you use when you created those squashed migrations. It might be a little bit ahead already. That's okay. Based on that, you're going to say, I'm going to tell Flyway to use a new schema version table, and I've added a date to this table name so that you know when it was created, just for convenience purposes. And you're going to give it a baseline, and you're going to say, oh, currently, my database version in production, you can just assume that it's on version, well, in this case, from the 13th of May, since we're using dates. That baseline version doesn't even need to correspond to an actual migration file. It just needs to be a logical version number. So what will happen now when you deploy is Flyway says, hey, I don't have that schema version 2017 something table yet, so I'm going to rebase. It's going to say, I'm going to assume that I'm already on some version that you provided as a baseline version. And then it will just look at the available migrations and say, everything that's newer than that baseline version, that I am still going to apply. So that would be all of the things that your developers created that's not yet been applied to the database. And with that, you now have a new schema version table with a baseline. You just have your 1 or 2 new squashed migrations plus some newer ones that you may have, and you can simply drop the old schema version table when you see fit and when you're confident that you no longer need to have that, right? So by using this combination of rebasing on an existing schema with a new table name, you can actually do this sort of thing quite easily and without any stop-the-world scenarios. And the final thing I want to talk about is basically a variation on this particular theme where you are currently working with a single application against a single database schema, but you want to migrate to more of a microservices-based architecture. And I've found that this is quite a common thing for many people to do, because very often microservices are the result of carving out services from an existing application, which makes a lot of sense for a lot of different reasons, but I won't go into that now. However, when you start doing this, you will find that typically extracting code from an existing code base is a lot easier than also moving all of the corresponding data to a separate database. Because when you have a single database, tables are very often shared between various bits of code. And rather than saying, I absolutely need to move this thing out into a separate database table, otherwise I will not be able to start the extraction of a new service, it may actually be okay to say, well, I'm going to live for a while at least with a shared database as part of the migration, right? Not as a best practice in itself. In that case, you can establish an ownership per table. So you can say, if I'm going to extract some code, that code is only reading from a table that is still maintained by the core application, or you can say that extracted code is going to be responsible for maintaining part of this schema, which includes a number of databases. Okay. And then the other code that's left in the old application is just going to read from that, but it's not responsible for maintaining that schema anymore. If that is something that you want to do, you can easily do that by using a variation on what I just showed you with rebasing. So what you're going to do is you're going to say, whenever I extract a new service out of my existing application, I'm going to provide a dedicated Flyway schema version table just for that service, just using a unique name. And whenever you do that, you're going to use baselining to say, well, I know that when I start up and this new service starts up for the first time against an existing database, that table is not going to be there yet. So I'm just going to provide it with a baseline version. And then any future changes that you make to whatever you consider to be owned by that new service will be migrations that are maintained in that new service. So what does that look like when you do that? You start with a single database schema that has a single schema version table for Flyway. And now you're going to extract some code. So in this example, we're going to say we have the remainder, most of the code will still remain in the core application. So we're going to call that core. But we're going to extract some stuff that's responsible for providing an administrative UI for internal use. And we have a lot of integration-related code, and we want to extract that as well. So what you can do then is you can say, well, for the core application itself, I'm going to basically do what I showed you in the previous pattern. I'm going to just squash migrations, and I'm going to provide a new table name. In this case, I'm going to call it schema version core. That will just start at some baseline. But I can do exactly the same thing for extracted services. So I can now extract an integration service and say, yeah, that's going to be responsible for a handful of tables in my database schema. So I'm just going to provide a baseline, and then from then on out, those tables will be maintained by that service. That also means when you do that, that the create table statements for all of the tables that are now under the control of the integration service will not be in the initial schema that is stored in the core application. Because that core application is just going to be a consumer of those tables. It's not going to create them itself anymore because it's no longer responsible for those tables. Now, obviously, this is, in a sense, an anti-pattern, right? A shared database between multiple services is something that you typically want to move away from. However, in my experience, you can get very real benefits in starting out like this, by still having separate services that you can deploy and develop in their own life cycles and that sort of thing. And especially if the parts of those tables that you share are very stable, you're not going to be in nearly as much pain as some people that advocate for microservices architectures would like you to believe. It depends, of course, all on your situation. But I have had great success with this. And we have actually had some projects where even though we said this is going to be a temporary situation, we actually never moved away from this. Not because we are lazy developers, although that's definitely part of that, but simply because we didn't really feel the pain that we anticipated originally with using this shared database schema. Because if the parts, like I said, that you're sharing are actually really stable, and you are not sharing things like, let's say, JPA entities in Java jars, but you're just sharing the logical expectations on parts of that database schema, this might actually be fairly okay, right? So that shows you some more advanced ways of applying this tool to your application as you're doing ongoing development. So in conclusion, I think that making sure that you have a way of automatically managing your database schema is really important. And I felt the pain of not doing that and doing it by hand, and I don't want to go back there. So I'm using Flyway in all of my projects now that involve a relational database. I think Flyway is a great tool to do this. I really like some of the choices that they made. They're not trying to be a tool where you can just write XML and it will be translated into SQL, like Liquibase, for example, does. They don't try to support things like doing rollbacks because they say, well, just make sure that you have a proper that you do test and that you have a proper backup, rather than trying to support something that you cannot actually provide 100% support for. And it's really flexible, right? So some of the things I showed you here, this is not stuff that you will find in the reference manual, like the pattern for squashing these things. But if you just understand how the tool works, you think about it a little bit, it does provide you with all of the building blocks to start doing all of this without any issues, basically. So in conclusion, if you're thinking about whether you should apply a tool like this to your projects, and you don't have one yet, stop thinking, stop waiting, start introducing it. Don't be scared of introducing this to an existing application, because with the baselining support in there, it's really easy to start applying Flyway, even if you have an existing project already. And after that, it's just a matter of profit, right? Which is always the step 3. So that's it.